Alright, this is 7.3 in advanced geometry, and we're still trying to prove triangles congruent, or parts of triangles, like getting some corresponding parts of those triangles after we prove them congruent. But the problem is that now the picture gets a lot more difficult to see, and they don't tell you what two triangles to prove congruent, so we've got to figure that out on our own. So the idea is the same, but man, is the problem just a little bit more challenging. So here's what we got to do. They give me some information. Let's start by marking what they give me. They give me segment AD. Whoa. Here's segment AD. Where do you put the tick mark? You got to put it right smack dab in the middle of it, or as close to the middle as you can without going over the top of something. So there's segment AD congruent to segment AE. So right there. And they also give me angle D congruent to angle E, so that's what I got. They want me to prove that segment EB is congruent to segment CD, so that's at the end. What we really want to do is find two triangles and prove them congruent to each other first. Well, that's where we use two different color highlighters today, right? So why don't you grab one highlighter, and here's what we want to do. We want to find the two triangles. So if they give me segment AD right here, this very first thing, I'm going to highlight segment AD. That's got to be one of the sides of the triangles I'm trying to prove congruent. They wouldn't give it to me if I wouldn't use it. All right, there's segment AD, and isn't it touching like this arc mark right here, this angle D? So angle D has got to be in the triangle that I want to prove congruent also. So what I'm going to do is I'm going to take my highlighter. Just watch me do this here. I'm going to take this highlighter and I'm going to follow this segment out, like follow this angle out, and stop to where I get at some intersection points. Right? So I'm going to stop right there for a second and say, okay, if I use this little segment right here, can I make a triangle out of these? And some people will say, well, yeah, you can make a triangle if you go right here. Well, sure, you could do that, but that wasn't really a segment in the picture. You have to be able to use some segments in the picture. So can you make a triangle out of it? Well, if you went right here, then that's not a triangle either because you got this overhang, so that doesn't work. So that tells you that you got to keep going when you want to highlight. If you go all the way up to here, right, use segment DC, can you make a triangle out of this information using some segments in the picture? And that's yes, you can do that right there. Do you see this red triangle? So what I then want to do is I found a triangle. I'm going to go off and I'm going to like kind of draw it separately in the picture. So also, if you want to use a pencil, that's fine. Just a little sketch. But here's what I just did. I got my red triangle right here. If you want to sketch it, highlight it the same color that you highlighted right here and put the vertices involved. You had an A right here, you have a D down here, and you have a C right here. Don't worry about that B. You know, that B is not really a part of, it's not one of the vertices of this triangle. So you really have triangle ADC right there. And then I'm going to put the markings that I already know in this picture. Segment AD had a single tick mark on it, so that's good. Angle D had a single arc mark in it, so that's good. The question is, this tick mark right here, what does it belong to? This tick mark does not belong to segment AC at all. It belongs to segment AE, right? Isn't that in the complete middle? So there is no tick mark in this red triangle right here. Now what I want to do is I want to go back with another color highlighter and find the other triangle, and I'm going to do that basically in the same order that I did, only using the other information. Segment AE had a single tick mark on it, so that's this guy right here. I'm going to highlight it green. Angle E is got to be an angle in that triangle, so I'm going to follow it out, and it's going to follow all the way out to here. One more time. Similarly. And then you want to connect them together and make this triangle out of it right here in green. And now I'm going to draw it separately, somewhere where I got room. And also kind of draw it in the same orientation that it looks like. This was an A, this was an E, and this right here is a B. And the markings that were in it was segment AE had a single tick mark in it, and angle E had a single arc mark in it. And this arc mark right here does not belong to segment AB, it belongs to segment AD, so that's really not a part of this green triangle. Woo! That is pretty difficult so far. I shouldn't say difficult, but that's a lot of work. Now, do I have enough information so far to prove these two triangles congruent? I do not. I'm looking at my separated pictures now. Okay, I got a side and an angle. I need more information. So let's go through our checklist. Is there a shared side between these two triangles? And you might say yes, you might say no. You got to have an entire segment in this overlapping picture highlighted both red and green at the same time. And some people go, well, segment AB is highlighted red and green. Well, the whole segment AB is highlighted green, right? It's in the green triangle, but it's not in the red triangle at all, segment AB. And if you look at your separated pictures, it's like, is there a segment AB in both triangles? There's one right here, but there's not one right here, so that doesn't work. And the same thing with segment AC. There's a segment AC in red, but there's not a segment AC in green, so the whole thing's not there, so there's not a shared side. Is there any parallel lines in the picture? No, there's no parallel lines. Are there any vertical angles in this picture? Yes, there are vertical angles in this picture, but there's vertical angles that aren't going to help us. Like people are like, well, this angle right here is vertical to this angle right here, and that's true. Those angles should be congruent to each other, but you see that those angles aren't really angles of these separated triangles that I'm trying to prove congruent to each other. This is angle. If you was to even name this angle, you couldn't even name it because they didn't even put like a vertex there of like, oh, I don't know, if I called that X, you know, you'd have to call that angle CX. You'd have to make up a vertex to even name that angle. So that's sort of a little clue also that says you're not going to use those angles in this problem because they didn't even put a vertex there. So even though it's true that those are vertical angles, they're not going to help me prove these two triangles congruent. So out of my checklist so far, no shared side, no parallel lines, vertical angles that don't help us. The other thing was, are there any isosceles triangles in the picture? If we think back to a couple days ago, like, you know, if there was some isosceles triangles, we could get some angles out of that. Well, I don't have any isosceles triangles, so whoa. The four things that we knew of on our checklist have exhausted. That means that our checklist isn't long enough. So here's what our checklist looks like so far. Was there a shared side? Nope, we didn't have any. Was there any parallel lines? Nope. Was there any vertical angles? Nope. Are there any isosceles triangles in the picture? No. So that means we got to add one more thing to our checklist. And instead of sharing a side, it is also possible for pictures to share angles. Are there any shared angles? And by the shared portion, it's still going to be the reflexive property. So let's go back to our picture here. Hey, are there any angles that are shared between this red triangle and this green triangle? And that's a big fat yes. If you look at this, let me highlight blue. Do you see this entire angle right here? This big blue angle is in both pictures. It's this angle A is in both triangles. In the red triangle, it's angle CAD, right? In the green triangle, it's angle EAB, right? That angle right there is in both triangles. So I could put an old double arc mark in it, and then I could go to my separated picture also. That's the important thing, is you got to put it in the real picture, but you also want to put it in the separated pictures also. Isn't angle A congruent to itself? So step 2, this shared angle, angle A, oops, if I could write it correctly, angle A is congruent to angle A for the same reason as the shared side, by the reflexive property of congruence. So that's cool. That now our checklist is basically complete. There's 5 total things on the checklist. Boom, boom. These 5 things. The shared angle, that's the new thing, and that's still going to be the reflexive property. So that's what we got. Now if you look at your separated picture, do you have enough information to prove those two triangles congruent? Well, yeah. Angle, side, angle. Angle, side, angle. So bingo. We can prove those two triangles congruent in step 3. Let's name the red one first. What do you want to call it? It doesn't matter what you call this red triangle. Let's call it angle ACD. But it does matter what you call the second triangle. And triangle ACD is congruent to, now I got to match these up. A in the red triangle has the double arc marks in it. It should correspond with A, which had the double arc marks in it also. C had no arc marks in it. Shouldn't it correspond with B, which has no arc marks in it? And D had the single arc mark. Shouldn't it correspond with E, which had the single arc mark? And the reason why those two triangles were congruent was by angle, side, angle congruence theorem. Now that I have proven these two triangles congruent, what should happen is any pair of corresponding parts should also be congruent to each other. And that would be what we're trying to prove right here. Step 4, let's go purple. Shouldn't segment EB be congruent to E comes last, D comes last, B comes second to last, C comes second to last? Shouldn't segment EB be congruent to segment DC? And I know they wrote it in stupid order. I just hate these problems. I should retype them all. But those segments should be congruent to each other because they are corresponding parts of congruent figures, so they should be congruent. So the goal on these is let's highlight and draw separate pictures, find the two triangles, prove them congruent, then once you get the triangles congruent, you'll get what you want by these parts will correspond to each other because they are corresponding parts of congruent figures, so they should be congruent. Whew! That was lots and lots and lots of work. Let's move to the next one. Let's write down all the given and mark it. They say segment AE is congruent to segment IV. Angle AEV, that's from A to E to V. This whole angle right here, angle AEV, let me just put a single arc mark in it now. Angle AEV is congruent to angle EVI. That's this whole angle right here. Prove that these two guys are congruent. So I got all that given. Now what I want to do is find the two triangles. So I'm going to grab one highlighter and I'm going to highlight basically what they gave me. First thing they gave me is segment AE. That segment has to be a segment in one of the triangles that I'm trying to prove congruent to each other. Is it touching any sort of markings whatsoever? Yes, it's touching this arc mark right here. So if I follow this angle out, isn't that the angle that we just marked, angle AEV? That angle's got to be in there. Now with those two green highlighted segments, can I make a triangle out of those? And by using a segment that's already there, isn't it true that you could do that as a triangle? What you should do before you try to find the other triangle is draw it separately and highlight it the same color. I just draw it in the color that I highlighted it, but you can draw it in pencil and highlight it green or whatever color you got. There's triangle AEV, and mark it right away. A's got a single tick mark, E's got a single arc mark, and there are no other marks. This arc mark right here does not belong to angle AVE. It belongs to angle EVI, so that's what you got going on right there. Then grab your other highlighter and find the other triangle. By doing this, segment IV has to be one of those. It's touching this big giant arc mark, so it's got to go right here. And then to make a triangle out of it, booyah. Then draw that triangle separately also. The reason why you want to pull them apart and draw them separately is so you can see why the two triangles are congruent. And this was an I, this was a V, and this was an E. And notice how my orientation of these triangles, like they look basically the same. It's all I did was just kind of slide that bad boy down here, and I slid this bad boy right here. They're kind of turned the same way and everything. So this has got a single tick mark on it. That's got a single arc mark on it right there. That's all my given information. Do I have enough information to prove these two triangles congruent? No, I do not. So let's go through the checklist. Number one, is there a shared side between the two triangles? And that means that the whole segment has to be highlighted green and red at the same time. And check out segment EV. It is completely highlighted green, and it is also completely highlighted red. And if you look at the separated picture, isn't there a segment EV in both pictures? There's a segment EV right here. There's a segment EV right here. So that is a shared side between those two triangles. So you can put double tick marks on it and put it in all three pictures. In the original overlapping picture and also in the separated pictures. Then we write it down. Segment EV is congruent to segment EV. Reason? It was the shared side. That's the reflexive property of congruence. Booyah. Got it written down. Now, do I have enough information to prove these two triangles congruent? That's where you look at these separated pictures. It's much easier to see. Side, angle, side. Side, angle, side. Yes, you do have enough information to prove those two triangles congruent. So that's step 3. I can say, I'll name the green triangle, whatever you want to call it. The green triangle is triangle AEV, rock and roll, AEV. I don't care what you call the first triangle, but I do care what you call the second triangle because they have to match in corresponding order. A in the green triangle had no arc marks in it, and it's where one tick mark and no tick marks combined. Like, you can't go with no arc marks because there's two angles with no arc marks in it, A and V. So you have to say, this is where one tick mark and no tick marks combine. Where one tick mark and no tick marks combine is at I. E had the arc mark in it in the green triangle. It should go with V, which had the arc mark in it in the red triangle. And V goes with where two tick marks and no tick marks combine, two tick marks and no tick marks combine at E. And the reason why those triangles were congruent was by side angle side congruence theorem. And then, now what did they want you to prove? They wanted you to prove that segment AV is congruent to segment IE. AV, IE aren't those corresponding parts, so we do not mark the last step. Remember, what we will say that segment AV is congruent to segment IE because they are corresponding parts of congruent figures, so they should be congruent to each other. Bada bing, baby, bada bing. Next, let's mark what they've given me. Segment PR is congruent to segment QS. Got that marked. Segment PS, whoa. Remember, you want to put those tick marks as close to the middle as possible without going over to the top of stuff. It's congruent to segment QR. And they want you to prove that these angles are congruent. So we've got to find the triangles. That's why I say let's highlight. And the first thing they gave me was segment PR. So boom, segment PR, which is right here. I'll highlight that red. Then you want to find some other segment that's got a marking on it that's touching this bad boy. And isn't it true? Well, okay, there's two of them, segment RQ and segment PS. If you choose segment RQ, which is bad, okay, like you don't want to choose that one because it's like, now you can't make a triangle out of those two red segments right here. So you want to choose a segment or an angle that's touching that you could make a triangle out of. And remember, you can't stop right there because this segment P blank doesn't even have any markings on it. It's segment PS that had some markings on it. So there's a triangle right there that you want to prove congruent. If you want to draw it separately, draw it separately. Alright, that's up to you if you need to draw things separately. I think it helps in very confusing situations, but sometimes the picture is pretty easy to see. It just depends. So that's what you got going on right there. The other triangle, green highlighter, they gave you this, segment QS. It's touching this guy, and I can make a triangle out of it right there. So that's what you got going on right there. And if you label, this was an S, this was a Q, and this was an R. You're going to the mall today, Billy. Blue, so you can see things a little bit better. Boom, boom. Do you have enough information to prove those two triangles congruent? No. So go through the checklist, and the first thing to check for is their shared side between those two triangles, and that's a big fat yes. Boom, boom, boom. Segment RS is congruent to segment RS by the reflexive property of congruence. And then you mark it in all three pictures if you have all three pictures drawn. Do you have enough information to prove those two triangles congruent? Oh yeah. Triangle, I'll call this one PRS, the red one PRS, is congruent to P corresponds with Q, R corresponds with S, and S corresponds with R by side, 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 congruence theorem. And then step 4, you finally get what you want. Angle P is congruent to angle Q because those are corresponding parts of congruent figures, so they should be congruent to each other. Excellent. Next one, pretty good proof right here. It's a challenger. So let's see what they give me. You don't have to write this down. I don't know why they write stuff like that down. G, J, K, and H are collinear. Well, that's something you can assume from a picture, so you don't have to write that down. But they tell you this segment GJ is congruent to segment HK. Okay, and segment GI, which is this guy, is congruent to segment HI. So they gave you that. All right. First thing you got to do is find the two triangles that you want to prove congruent. Then, actually, once you find them, then prove them congruent. So I'll grab my highlighter and I will say, okay, here's the first thing it gave me, segment GJ. And now I want to connect it together with segments that are marked already. And isn't it touching this guy that's got two arc marks on it? So yes, and let me draw that a little bit better. And now, can I make a triangle out of these two green segments? Well, yes, I can, and the only way I can make a triangle is to go straight down there. Right, there's a triangle. And to find the other triangle, I'll switch colors. They gave me segment HK, which is right here. It's touching this guy. And then to make a triangle, you go straight down there, and I'll draw that a little bit better. And then what we did before was we pulled them apart and drew them separately. Well, honestly, those are already drawn separately. They're not overlapping each other at all. So if you want to pull them apart, go ahead. But if you don't have to because they're already pulled apart. Do you have enough information to prove those two triangles congruent? Right now, no. You just got some sides. So let's go through the checklist. Is there a shared side between those two triangles? No, because I don't have an angle. I don't have a side that's highlighted both green and red. Is there parallel lines? No. Is there vertical angles? No. There's only two things left on our checklist. And those two things are there any isosceles triangles or are there any shared angles in the picture? Well, honestly, the easiest one to deal with out of that is, are there any shared angles? Because the reason for that's the reflexive property. If there's isosceles triangles, you got a couple of choices of what you can do, and that's a lot of work. So let's check step 5 first. Are there any shared angles in this picture? And a lot of people want to say, oh yeah, baby, you got angle I and angle I in each triangle, and that's not really going to work, because if you name this angle right here, it's angle GIJ. If you name this angle right here, it's angle HIK, and those are not the same name. If you was going to mark them, you would only put one arc mark. Like if we go back to that first one that we did like that, if you was going to mark it, you only put the double arc mark in the overlapping picture once, right? It's like you only marked with one set of markings. If you go back here to our problem that we're on right now, you'd have to put an arc mark there and an arc mark there. You put two different sets of markings. That's not a shared angle. So that doesn't fly. So there are no shared angles, right? That's a different angle. The only thing left is, are there any isosceles triangles in the picture? So what do you think? Are there any isosceles triangles in the picture? What do you think about the big blue triangle right here? Is it isosceles? And that answer is a big fat yes. It's triangle GIH, and doesn't it have at least two equal sides? So that's what we can do for step 2 right here. Let me get rid of this. Is that we can say that triangle GIH is isosceles. And remember, you got to write that down. Oops, I need a triangle symbol. Triangle GIH is isosceles. Why is it isosceles? Because it's got at least two equal sides, and that's the definition of an isosceles triangle. Rock on. So I got an isosceles triangle. Whoop-de-doo. Who cares if we got an isosceles triangle? What do you get out of an isosceles triangle? Well, can't we get some angles the same? Shouldn't this angle be the same as that angle? Aren't those the base angles of that isosceles triangle? So step 3 is, I can call that angle G if you want to. You can call it by 3 letters, but it's the only angle with G for a vertex. Angle G is congruent to angle H, because those are the base angles of that isosceles triangle. So that's the isosceles triangle base angle theorem, which says so. And remember, you can't use the base angle theorem in a proof unless it's written that you have an isosceles triangle. So we did need the purple steps right there. We had to say that first. So now that I have that, now check it out. Don't I have side angle side situation going? So yes, I can say that triangle, I'll call this one GIJ, is congruent to triangle. G goes with H, I corresponds with I, and J corresponds with K. So step 4, that's because of side angle side congruence theorem. That's rock and roll. And then to prove this, segment JI congruent to segment KI, those are corresponding parts. So I finally get segment JI congruent to segment KI because they are corresponding parts of congruent figures, so they should be congruent. Alright, last one of the worksheet, man. Trying to prove these two triangles congruent. So that's nice. They tell us which two triangles, but they give us a regular hexagon. And let's remember what it means to be a regular hexagon. It means that all 6 sides of these guys are the same, and all 6 angles of this dude are the same. But you know, we really don't need all 6 sides. I don't need this, this, and excuse me, to all be the same, because I'm just trying to prove that this triangle is the same as this triangle. So if I magically pull them apart, I'm talking about this pink triangle right here, triangle DEF, and this green triangle right here, triangle EFG. So all they give me that is a regular hexagon, so let's go marking time. You know, what I do know is I need this dude, and this dude. Like, out of the 6 sides that are the same, I need these 3. So segment DE, bada bing, segment EF, bada bing, which he's here twice, and segment FG if I was to be marking stuff in my separate triangle. So that's kind of weird to write that down, because there's 3 things congruent to each other. It's segment DE is congruent to segment EF, which is also congruent to segment FG. We're just going to say that they're all congruent to each other, and the reason is the definition of regular. You could say hexagon if you wanted to, you could say polygon. We'll just say hexagon in this case. But the magic word is regular, because that's part of the meaning of regular. All the sides are the same. Now, if you look at the 2 pulled apart triangles, you don't have enough info, right? You just got a couple of sides. We need some angles. Well, what's also true about the old regular polygons is all of these big old angles are congruent to each other. So this whole angle here, this angle DEF, like this guy, has to be the same as this whole angle EFG, like right here. So we can go ahead and write them down. Let's do that as a separate step. Angle DEF is congruent to angle EFG, also for the same reason, definition of regular hexagon. Yeah, I know you could put those 2 things in the same step, but I'm a big fan of doing them separate when you're talking about sides up here and angles down here. So got to have it marked in the main picture, and now we have enough information to prove the 2 triangles congruent. So boom, triangle EFG is congruent to triangle FED by side angle side congruence theorem. So when we're doing our homework tonight, I feel that highlighting is a definite, and pulling apart the 2 triangles makes our vision so much easier. So do that, and if you need some help, come on in and let us know. We'll be happy to help you. All right, have a good one.